Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the last video we have learned the working construction of PN junction diode. Now we are more familiar with the operation of PN junction diode. Let us graphically analyze how that current and voltage characteristics of PN junction diodes are. We all learn the operation of PN junction diode under the category of forward bias and reverse bias. These two forward and reverse bias operation, current and voltage characteristics, we will graphically map and we will show that this is how the relationship between external voltage supply, your junction potential, minority charge carrier current and majority charge carrier current as well. Okay, so let us graphically analyze this. This is voltage, this is the current. I will represent it in small letter IF, that is forward current. This is V. I'll write it as few things over here. IF is nothing but the forward current. V is nothing but the voltage supply. Now in the first quadrant, I have applied positive voltage. See this picture. In this particular picture, we have learned the forward bias operation where your PN junction potential P and N across, I have applied positive potential, right? So whatever voltage V I have applied over here is positive. See here, this is the positive, so I can say that whatever current will flow will also flow from positive to negative, that is anode to cathode. So this quadrant, in this particular quadrant, we will map your forward bias condition. Okay, now how to map it? First of all, in this particular case, we have learned that this current will increases exponentially as the external voltage increases. So this structure will be like this. This graph will be like this, and where this is nothing but the VD, that is called as diode potential or barrier potential, or also it is called as potential which is nothing but at the junction, that's called as a junction potential. The relationship is expressed mathematically as this IF is equal to IO into exponential part of VD divided by VT. Now what is VT? VT is nothing but the thermal voltage. Okay, and that thermal voltage is nearly about 26 millivolts if I'm talking about room temperature. Okay, so what is VT? VT is nothing but thermal voltage, and that is nearly about 26 millivolts. This is important as far as BJT construction, bipolar junction transistor construction, AC analysis and DC analysis is concerned. This is very important that thermal voltage is. So as far as mathematical expression is concerned, IF is equal to IO e to the power VD divided by VT. What is VD? VD is nothing but the junction potential. We will write it over here. What is VD? VD is nothing but junction potential. And one more thing, what is IO? IO is nothing but minority charge carrier current. And this minority charge carrier current is responsible for reverse bias as well. Now, as far as forward bias situation is concerned, this is all clear. Now if we want to form the resistance Now I know that the relationship between the resistance, if we form this kind of non-linear curve, we will say this is nothing but the tangent. If I draw tangent between these two, then we'll be getting the relationship between the change in the current and change in the voltage, that is delta V. This change in the current and change in the voltage will give you dynamic resistance. So this dynamic resistance is also called as a dynamic resistance because it's dynamically changing, it's changing continuously. So we say that small ro, or you can also name it as rd, नाम में कुछ problem नहीं है. Ro is nothing but change in V with respect to change in IF. Okay, and that is nothing but the inverse of that of slope. So it is called as inverse of slope. So if we take the slope of this particular curve, instantaneous slope of that curve at this particular point P, then we can say that inverse of that slope is nothing but the resistance at that particular point of operation. Okay, this is how we have learned the characteristics of forward bias situation. Now come to the point of reverse bias situation. I know that, see, this is the operation of reverse bias that we have learned. P and N junction potential is Vd, and the PN junction externally we have applied the negative potential, that is V. So we have to move towards the negative x-axis as far as characteristics are concerned. But whatever current will flow, the amount of current will flow is very less, that is magnitude is very less. But as far as direction is concerned, it is exactly opposite to that of forward bias. So what I will get the operation under the third quadrant. So in this third quadrant we will be getting the operation of reverse bias. So we'll name this as the third quadrant for a reverse bias situation. But keep this in mind that whatever current will flow with very less magnitude. And again, at this particular point we will be getting very high amount of current, and that is nothing but the concept of breakdown, and that's why it is called as breakdown region. This is called as breakdown region, and the voltage at which the breakdown occurs is called as breakdown voltage. So again we will get one term that is called as VBR, that is nothing but breakdown voltage. The voltage after which diode goes into the breakdown region, that is called as breakdown voltage, before which the reverse saturation current will flow with a very less amount in terms of nanoampere or picoampere as well. So it's a very less amount, but if current will flow in a sudden steep current will flow without changing any voltage, also I will be getting very high amount of incremental amount of current which is flowing in exactly opposite direction. There is possibility of damaging of the diode. So that's why we have to design our diode with very nice precaution that the voltage which should reach under the VBR. So I have to operate my diode under this VBR voltage, right? So these are nothing but the characteristics of diode. About the breakdown region, we are having less knowledge about this breakdowns of the diode. So in the next videos we will learn that particular concept, how breakdown gets occurred, what are the types of breakdowns, and how it will get affected to the operation of diode. So stay tuned for that video. As far as this particular video is concerned, we have learned complete characteristics of diode. In the next few videos we will learn the breakdown region types and little more. Thank you very much for learning EDC1 along with me. Subscribe this particular channel, learn this particular EDC1 along with me. Thank you so much.